Assalamualaikum warahmatullahi wabarakatuh, and very good buddy, very good day to everybody. So now we are moved to another topic in this chapter number 8 in the referring to the dynamics textbook. This one the first chapter, but in our static and dynamic, this one is should be the chapter number 8. So in this topic we want to study about motion of a projectile. So the objective on this lesson is the student you should be able to analyze the free flight motion of a projectile. Okay, so basically the projectile motion can be treated as two rectilinear motion, one in the horizontal direction experiencing the zero acceleration, and the other in the vertical direction experiencing the constant acceleration from the gravity. Okay, so meaning that in projectile, so in the horizontal direction, our assumption is that acceleration is constant, is equal to 0, and then vertical direction, acceleration is also constant, and also is create the gravitational constant. Okay. So what be the kinematic equation for in horizontal? For example, from point this particular point, the position is moving. It's a projectile from here to here, for example. So since Ex equal to 0 in horizontal direction, the velocity in horizontal direction remains constant. So Vx is equal to V naught x, and the position in x direction can be determined by the x here is equal to x naught plus V naught x multiplied by t. So why is Ex equal to 0? Because this one here, we are only focusing what assumption must be made if the moment is through the air. Okay, this one it should be a little bit homework for you. Okay, we can discuss in the next class during your tutorial why would the Ex equal to 0 in our assumption here. So only focus in acceleration in the y component. Okay, so whereby the vertical motion, so because our reference plane positive y-axis to the up, directed upward, and then so but the acceleration g is going downward, so the ay is equal to minus g. So this one kinematic equation that we have learned in the kinematics in the linear motion. So Vy is equal to V naught y minus g, because this one is the A is equal to minus g. So y is the y naught plus V naught y t minus half gt square, because g is minus a here is the minus g. Again, V naught y square, Vy square is equal to V naught y square minus 2as, but here a is minus g as a y minus y naught. For any given problem, only two of these three equations can be used. Why? So in order to answer this equation, so we will do some exercises. Or perhaps if you can't really guess, or so can't really get why is only two equations used, we will do again another tutorial and there's some more problems. So that's why you can learn by yourself. Okay, we can see this example. So given the V is 10 meter per second, and then the angle is 30 degree. So we need to find the horizontal distance intervals. So from A to C here, what will distance A to C, and also the VC, so the velocity when it hit the ground at the point C here. So what we plan, so apply the kinematic relation in x and y direction. Okay, so using VA, because we have two component x, component of y. So VAX 10 cos 30 and VAY 10 sin 30. So Vx mean we can get the 10 cos 30. So Vy, because the expression is 0, so Vx we just left a V naught x. So Vy is 10 sin 30 minus 9.81 t. So x is equal to 10 cos 30 t. So the A expression is a 0 here, so only left the first part. So y is equal to 10 sin 30 t minus half 9.81 t square. Okay, solving all this equation, y equal to 0, at c here, so 0 here, so we can get the t is equal to 0 and also 1.019. So this equation only one unknown. Okay, so we have the equation y is equal to 10 sine 30 t minus half 9.81 t square. So at the C position C, y equal to 0 at C. So we substitute 0 into this equation. So we have the 10 sine 30 t minus half 9.81 t square. So only the one unknown. So we can solve the equation. So whereby using your scientific calculator, you can get the t either 0 and also 1.019 second. So t equal to 0 at A, and then t equals to 1.019 second at point C. Okay, so that we have the time taken at we have already find the time taken at point C. So we need to find the velocity. We need to find the velocity and we're reaching the at point C here. So we have Vy 10 to power 10 my this okay, so we need to find the velocity at the component of the component of the at this C here. So we have the Vcx, so 10 meter per second multiplied by cos 30. So we have the component of the Vcx here, so 8.66, whereby the Vci, so we are using this equation. So this Vci, okay, so we have Vy 10 sine 30 minus 9.81 t. So we use this equation again. So 10 to minus sine 30, 10 multiplied sine 30 minus 9.81 multiplied by time t is 1.019. So whereby the velocity in x component, the acceleration becomes 0. So only is equal to the initial velocity. So Vax is equal to Vcx by the Vcy. So we can use the t. So t is 1.019. So we get the -5 or 5 meter per second downward. So the component velocity, the magnitude of the velocity. So we have the Vcx here and the Vcy here. So Vcx means 8.66 square plus Vcy minus 5 square. So the product of these two addition. So we can get the this square root. So we have the 10 meter per second. So finally, the distance from A to C is given by the x is equal to 10 multiplied cos theta t. So we have the t is 1.019. So we substitute t multiplied by cos 30 multiplied by 1.019. So we get the 8.83 meters. So from A to C is 8.83 meter. Okay, we will stop here and then we will see the next topic. In next topic in the curved linear motion, also in the normal tangential component. Okay, see you in next video, in next class. Thank you, bye bye.